Ladies and gentlemen, my name is Nxumalo. I'm studying at the University of Zululand. I'm currently doing my postgraduate in the University of Zululand this year, specializing in atmospheric science. Well, ladies and gentlemen, I'm going to give you a topic today about paleoclimate. The word paleo is derived from the Greek Latin word meaning ancient, meaning the past, and the word climate. We know that climate and weather are two different things, but they work together hand in hand. You cannot wake up today and say climate has changed or climate is behaving different today as it from was yesterday. You can only say that with weather that the weather today is different, the weather is windy, the weather is raining, the weather is like this and like that. Okay, now the word paleoclimate, it means the past climate or the ancient climate over the past million or billions of years. How does this help us? Well, ladies and gentlemen, let me take you to the outline of this presentation I'm going to do today. Okay, what are paleoclimates? As I've mentioned and I've described the paleoclimate, and why study paleoclimate? How is that is going to help us as the body of knowledge, and the possible causes of paleoclimate. What causes the paleoclimate? What causes this shift and change of the climate that we're talking about today? You hear people talking about greenhouse gases. What are the proxies? And also we're going to go to the proxies, and we're going to go to clavage cycles. The guide explains it very well, and we're going to go to glacial, interglacial, and we're going to go to case study of the paleoclimate. The objective of this presentation is to understand and add another dimension to the story of the paleoclimate, of the habitable planet ideology, and to set an awareness about the science behind the past current climate events. Okay, why do we mean by paleoclimates? Ladies and gentlemen, let's go straight to the questions that are usually asked by the scientists. Ask questions such as, what happened? We love to know what happened before, because now we hear people talking about this climate that is changing and it's mainly influenced by the greenhouse gases. What happened when humans were not there before, and why did it happen? Why such a change of climate happened, and why is it the way forward? How can we predict and how can we prevent such climate events such as floods to happen, such as earthquakes to happen again, such as more levels of heat to happen again? What is the way forward? How can we predict these things, and how can we avoid future problems from these things? Okay, like the global average temperature, we can see that in the 5-year average, climate has been increasing with 1 degree Celsius. The global average temperature has risen approximately about 1 degree Celsius over the last century. Why is that? Okay, why study past climate? Could provide answers to such questions as, has our planet always been habitable, or has our climate always been this way? Is the last century of climate change unprecedented relative to the last 500, 2000 and 20,000 years ago? Can we find evidence in the past paleoclimate record for mechanisms of climate forcings that could be causing recent climate change? Has climate been moving from warm, cold to warm? Or has it been moving from warm, cold to warm, or cold, warm, warm, warm? We don't know. Let's go through the slide. Causes of paleoclimate changes. Despite the uncertainty, possibly clues to climate include changes in the concentration of the greenhouse gases in the atmosphere. You know, Gore has been talking much about these greenhouse gases in the States, changes in the solar output, changes in the Earth orbit, and changes in the distribution of continents. Of course, we're talking about the continental drift back way then in the continental pangai, where the continents work together. Changes in the solar output. Radiation varies from 0.1 to 0.2%. This tells us that the radiation variation has increased by 0.1 over the past billion years ago, and the sunspot cycles of 11 to 22 years are attributed to solar radiation cycles. Is this true? Let's continue. Studies of stellar evolution says the stars like the sun brighten slowly over billions of years. 30% of diameter 3G. Are these facts sufficient enough to explain the great ice ages? Well, when we're talking about the high levels of heat becoming more intense due to climate, do ice ages stay there? No, they will decrease. And why did they decrease? Let's continue. Changes in the Earth's orbit. Medium-term changes in the paleoclimates are best explained using Milankovitch cycles. What is Milankovitch cycles? Milankovitch cycles is the study that has been done using the forces of physics, or centrifugal forces is also part of these Milankovitch cycles, because it studies the way the Earth revolves and spins around the sun. And how do we know the shape of the Earth? Through seismic waves that the Earth, it is spherically and cylindrically. It bulges in the equatorial regions. The Earth is not round due to the seismic waves that we find. Key issues of paleoclimates. The instrument record extends back to only about 150 years. So what do we know about 150 years going backward from then? We don't know, because the key instrument that we're using, they are not allowing us to do so. So this is as a challenge to people developing science instrumental to be used in the future. The paleoclimatologist uses natural records of climate called proxies climate data. We're gonna go into proxies. Well, we need more and more evidence to say what has been happening before and how did it happen. The proxies are indirect forms of evidence used to infer climate. Of course, we need to have something to study with, something to develop our studies from. We then have proxies. We're gonna go into proxies now. Well, ladies and gentlemen, examples of proxies, like example number one, the tree rings. The tree rings, they tell us that over the past years, or that the tree has left. Then we know that when you look into these rings, the ring, each ring represents each year. So when the ring is dark, it tells us that the tree has been living in a very dry period, and that means the climate was not well and friendly and hostile in that year. But when this tree ring is like thick enough, and then we see that, oh, this has been a wet period, that means in this particular year, the year has been receiving more and more rainfall. As we see these rings increase and increase and increase, it tells us that this tree, maybe if it had lived over the past 30 years, then it can tell us and give us a proxy, an slight indication of how that this climate has been behaving over these past climates of the 30 years. Okay, the sedimental cores, the sediments, the way they are stacked in different layers, like you have your first layer, the second layer over these past years. It can tell you that over this horizon, it was very wet, and because you will see with the sediments and also the minerals deposit that are there, minerals that are only available when we have the wet and the very friendly environment. But when these sediments are stacked on top of each other and they are highly compacted, it shows that maybe there were high levels of heat whereby the climate was not friendly enough to allow these natural evaporant sediments to go through a very hostile and friendly year. The ice core edges, you see with the evidence of photos that over the Greenland, Scotland, Scandinavia, you name them, that the ice core edges have been shifted over the past years. It's no longer the same as before. And why is that? It might be the levels of heat has risen over the past different kilometer years ago. Going straight to coral reefs. Coral reefs can also tell us the prediction, because when looking at coral reefs, yes, of course, studying the different continental movement, what happens on the coral reefs as the changes of climate continue over the past years. The stable isotopes, we're going to get into that one later. The pollen, we're going to get into that one later as well. The sedimental causes I've explained today, and you can see there 1 year, the machine that we use, it gives you 1 year, different sedimental deposits that have been happening in that 1 year. Sedimental cores can be taken from lakes, the shallow ocean, or the deep ocean. In some cases, the thickness of these layers can be used to infer past climate. In other cases, these layers are composed of organic material that can be analyzed for other climate proxies. Isotopes, the levels of oxygen in the atmosphere. As you know that oxygen is part and parcel of the greenhouse gases. Is the levels of oxygen increasing in the atmosphere or decreasing? We use the studies of the mechanisms and the instruments of atmospheric sciences to study the levels of oxygen evident in the atmosphere. The coral reefs can be friendly into some certain climates and can be very, very, very harsh and unfriendly into some certain climates and climatological years. The coral reefs are composed of calcium and carbonate. This carbonate contains isotopes of oxygen that can be used to determine the water temperature when and where the coral reefs grew. Well, if these environments are not friendly and hostile enough, then we find that there is no life continuously continuing in that particular levels. The ice core edges, and then you see here in the graph, you find that the ice core edges, they have been very high. The temperature, when the temperature is very high, you find that the ice core edges, they are decreasing. But when the temperature is very low, and then you find that the ice core edges are increasing. Well, this is highly expected. When the levels of heat increase, the ice core edges will decrease, because these work hand in hand, and they work like the graphs. The temperature rings, the tree growth influenced by climate. These patterns can be seen in tree rings width and isotopic composition. As I've mentioned, the tree rings width tells us and it indicates a different year of the tree that it has lived over the past 1,000 years ago. The paleoclimate, evidential climate, the PET representation, a short period of maximum temperature lasting about 100 Ka during the past paleoclimatic episode. It's believed to be caused by an abrupt increase methane gas to the atmosphere. This is the belief, it's not the proof that this is the reason why past climates have been behaving like this. And you can see the Ecocene climate optimum, whereby the paleoclimate and the thermal maximum, we find it. Well, what is the main cause of this? Might it be the greenhouse gases? Might it be the levels of heat increasing in the atmosphere? Let's continue. Well, could there be any analogy for current anthropogenic climate change? About 56 million years ago, there were no human emission, but there was an abrupt increase in Earth's temperature. Well, this is now going opposite to what Al Gore has been saying. Well, in no further issue, is there any similarity with what occurred during the PETM and the current human-induced temperature increase? Do we run the risk of replacing the big carbon discharge evident by burning fossil fuels at the rate where we are now? We don't know. Conclusion. It's clear that Earth's climate has not been stable in the past, and it's continuing to change. How do we know that? We see that there's this evidence that we have found in the coral reefs, the isotopes, whereby we talked about the tree rings, and we know that Earth has not always been habitable. Why do we say that? Over the past million and billion years ago, we see records that Earth has been behaving constantly when it comes to temperatures, when it comes to greenhouse gases, not greenhouse gases in particular, but when it comes to the evidence that we have been studying over the past years. The great ice ages were caused by processes of continental drift and greenhouse effects. What do we mean about continental drift? During the billion years ago, there was this guy, Alfred Wenger. He studied continents and he came up with evidence saying that continents were once joined together over the past by the continental Pangaea, when they started to drift, where the continental drift started, and when they started moving and they were hitting each other and they were drifting apart, the convergence process took place whereby two continental plates were converging one another, and there was heat generated there, and Earth tried to emit this heat through the volcanic eruption, whereby Earth is trying to erupt and explode gases and carbon dioxide gases and methane gases started to result then, and today we're saying these gases, we're calling them greenhouse gases. This has been resulting and been happening over the past billion and million years ago. All of examples used individually or together can help piece together the past climate of a particular time period of region. Talking about region, I'm living in a small town called Mpangeni, and when you travel to town, you will find regions whereby farmers will complain that on this other side of the road it rains a lot, and on this other side of the road it's dry. Why is that? This is the different geological behavior of the earth and the different grid patterns of the atmospheric processes, whereby you find that on the other side it will rain, on the other side it won't rain. This is mainly also influenced by the behavior of the climate, and we know that in climate we have regions. You'll find that it will rain into some certain area and not rain into some certain area, and also people like to confuse this in the mountainous regions, whereby you find that on this other side that we call the windward process, whereby the wind come and converges, starting the processes of rainfall up until the particle made the dust, and then it merge and fuse through coalescence process, and rainfall will be going down, and so as a result it will fail to resist the force of gravity. But you'll find that on the other side it's dry, because there are no wind and there are no friendly wind that are hitting that other side, because they have been blocked by the elevation of the mountain, whereby you'll find on the other side it's raining. So people like to confuse this, get this processes. And ladies and gentlemen, that all was my presentation of today, and